All right, so here if we just add 2 to both sides, we see that x equals 2. Here if we subtract 1 and divide by 2, x is equal to negative 1/2. If we add 5 to both sides here, x equals 5. Here if we subtract 2, divide by 3, x equals negative 2/3. Now the only difference is when they say find the zeros, you'll leave that as your answer. But when they find the intercept, you will put that as 2, 0, negative 1/2, 0, 5, 0. So that's the only difference really between the two. Okay, so these are actually your zeros. So you do not write as an intercept. Okay, you just leave it like that. All right. Any questions on that one? All right. I'll do this one. Yep, that's a good one. All right. Okay, so sometimes you have to go back to your days of factoring to do some of these, and we'll do just one quick example. So you want to find the zeros of the polynomial. Say f of x is equal to x to the third plus 7x squared minus 9x minus 63. Okay, let me just rewrite that. Uh-oh. Yep, plus 7x squared minus 9x minus 63. Okay, so before they had it all factored for us, nice and neat, but this time they don't. Okay, so with this one, you can actually factor by grouping. Okay. If you remember factoring by grouping, you get the 4 terms, you kind of break them down into 2 smaller terms. Okay. So you take the greatest common factor of these 2 and the greatest common factor of those 2. So here you can factor out an x squared, which leaves you with x plus 7. Okay. Here you can actually factor out a negative 9, which leaves you with x plus 7. Okay. Remember, your goal is to have these 2 match. Okay. Once they match, you can just factor those 2 out. Oh, might as well say f of x. So you have x plus 7. Once you factor those out, what's left goes in the next. X squared minus 9. Okay. So we're good here. The only problem is now we have a difference of squares. Okay, and if you remember difference of squares, x squared minus 9, you can rewrite that as x squared minus 3 squared. So when you have your difference of squares, it will be x plus 3, x minus 3. All right, so that means our f of x is going to equal x plus 7, x minus 3, and x plus 3. Okay, so now we just find our zeros. So if we find the zeros, we set f of x equal to 0. Okay, so that means we have our x plus 7 times x minus 3 times x plus 3 equals 0. Okay, so we get each one of those, set those to 0, and we'll have our zeros. Saying 0 an awful lot. So x plus 7 equals 0, x minus 3 equals 0, and x plus 3 equals 0. Okay. So if we subtract 7 from both sides, x equals -7. We add 3 to both sides here, x equals 3. If we subtract 3 here, x equals -3. And those are your zeros. All right. Any questions on that one? All right. Okay. Now for these next ones, they're going to give you a graph, and when they give you the graph, you're going to have to create the function from the graph. So we have the steps, so it's not too bad once you do it a few times. All right, so first we're going to write down the steps. Okay, so if we have, let's say, our or a factored polynomial in a general form. Okay, so not just our regular A1, A2, A3, AN, etc. This is when it's all factored out. So our factored polynomial general form. Okay, so that's if you have some f of x is equal to some lead coefficient times x minus x1 raised to some power, we'll call that P1. Okay, so if you have x minus x2 raised to some power P2, and x minus some x3 raised to the power P3. And it keeps on going until you get to some x minus x of some number raised to some number. Okay, so where P, we'll call that P sub I, equals the power of the factor. Okay. But in most of these, you'll hear them call it the multiplicity of the factor. Right, so whenever you hear multiplicity of the factor, they just basically mean the power. All right, so let's say if we have our steps for creating a formula. From a given graph. Okay, so your first step, you're going to find all the x-intercepts. Okay, and your x-intercept, if you look at the formula, those are your x1s, x2s, x3s. Those are your x-intercepts. So x1, x2, x3, and it goes all the way to your xn. Okay, just the x by itself is just x. You don't have to change those. But all the ones with the sub values, those are the ones you're going to change. Okay, so 2, you're going to discover the multiplicity of each power. or not discover, determine. I mean, power of each factor, sorry about that. Multiplicity, which is just a fancy way to say power of each factor. Okay. Now there are two ways you can do this. Say for 2a, if you have a graph and it crosses completely, then you know that power is going to be odd. And I'll show you examples of each of these when we do the example. So if the graph crosses the x-axis, the multiplicity of that factor is odd. Now, if it just barely touches or kind of bounces off, then you know it's going to be even. So if the graph, let's say, touches or bounces, I can say bounces off is one term, the x-axis, the multiplicity of that factor is even. Okay, so step 3, you're going to find the smallest degree possible for the whole polynomial that will make step 2 true. And I actually have a little tip where you kind of can skip step 3, but that would make step 2 true. Okay. For step 4, the last step is we're going to solve for a. Because out of all of this, they don't give you the actual value of a. So we're going to solve for a. Okay. Okay, solve for a. And doing that using the y-intercept is usually the easiest way to do that. And this determines the stretch and shrink, vertical stretching and vertical shrinking. That up for a little bit. Okay, so this is where you can really kind of skip step 3. So if a polynomial has degree n, then there are at most n minus 1 turning points. Okay, which is just a fancy way of saying that the degree is going to equal the number of turning points plus 1. Okay, and we'll go into how you can see the turning points and everything. Here we go. Alright, so let's say, for example, and this one I actually had to print up, so these will be uploaded. Okay, if you want to write the formula for the polynomial shown there. Okay, so remember your first step. Okay, so before we get started, these are where you call your turning points, where it's decreasing here, then it changes direction, then changes direction. Those are your turning points. Okay, so if there are 3 turning points, then that means there are 4 degrees. So there are 3 turning points. So the degree is 4. Okay, so that completely eliminated step 3. You don't even have to worry about step 3 anymore. All right. Any questions on that step? All right. Okay, so we know here, let me move this over some. Okay, so we know your first step, you have to find your x-intercepts. Okay, so we can see here, it crosses the x-axis at -3, 2, and 5. Uh-oh. Might as well put them all in one. Okay, so since we have 3, we'll start with 3 factors. So we'll start with f of x equals a, x minus x1 to some p1. Clean that up some. X minus x2, some power, times x minus x3 to some power. Okay. We don't know just yet what power, but we'll figure that out. All right. So if we go to our second step, okay, you see at -3, it crosses right through. So it crosses through, bless you, x equals -3. So this particular one is going to have an odd degree. Because remember, when it crosses through, it's going to be odd. If it bounces off, it's going to be even. Okay, so we see at x equals 2, it kind of bounces off. Okay, so we know that particular degree is going to be even. Oh, even degree. Okay, and we can see for 5, it kind of crosses right through it. So we know that's going to be an odd degree. Okay, so kind of for your third step is where we plug everything in. Because remember, this is your x1, x2, and your x3. Okay, so we just plug everything into that formula there. So f of x is going to equal a x minus -3. And we still don't know p of 1 yet, times x minus x2, which is x minus 2, times x minus x3, which is x minus 5. Okay. Now the one thing we know is that this one is odd, this one's an even degree, and this one's odd. So if we make this 2, 1, and 1, we have our degree of 4. So you have a x plus 3, because minus negative is just plus, times x minus 2 squared, times x minus 5. Uh-oh. So we have our degree 4. Which we kind of knew way up there. Okay, so any questions so far? All right. Okay, now for your fourth step, we know all of this, but we don't know a yet. Okay, so for your fourth step, that's when you're going to solve for a. Okay, so you can see right up here from the graph, when x is equal to 0, y is equal to -2. So you know your y-intercept. Oh, move that up some. And we know that's from the graph. Uh-oh. Is 0, -2. Okay, and remember, this is your